1.5 is another technique of factoring that you're going to add to your tool belt. Factoring is basically taking anything that is a polynomial that's adding them together, and you're breaking it up and turning it into groups of multiplication. That's what this is. I know that there's one question in your homework that's going to say, okay, here's a volume. What is a possible length, width, and height? It means you're basically factoring this into its possible groups. That's what we're going to do. Factor by grouping is a form of factoring that we primarily use when there are 4 terms. 1, 2, 3, 4 things. When there are 4 things, you're going to use this method more than most. Now, what I did to organize you is I put down an A, B, and a C of what we're going to do. And I think if you see this color-coded, I think it actually makes it make more sense. So what I'm going to do is I'm going to do this first step, and I'm going to show you, because number 2 is already done for us. We're going to factor out a GCF from terms 1 and 2. Okay? So there is no GCF of all 4 terms. But what I can do is I can look at these 2 terms, and I can factor out a GCF from terms 1 and 3, or 1 and 2. What goes into both of these is 5s squared. If you were to factor out a 5s squared, you would be left with this 2s plus 5. This times that is this, and this times that is this. Do you agree with what I've done in red?
Yes.
Good. Now what I want you to understand is we've only factored out this thing from this red group, and what we're doing to that red group is we're adding an 8s and we're adding a 20. It's still addition. It's still addition. I want to make sure you understand we're still putting things together with it. It's not multiplication. Now what we're going to do is we're going to factor out a GCF from terms 3 and 4. It is still addition. Here's 3 and 4. Circling it in blue. And we're adding this blue group to the red group. It's still addition. And when we pull out the GCF of these 2 terms, that is still being added to the red group, which is why there's a plus sign there. I'm going to look, and the GCF of 8s plus 20 is a 4, and 4 times 2s is 8s, and 4 times the 5 is 20. This blue group is still being added to that red group, and it's not all multiplication. What we've done with the red step and the blue step is we've done step A, which is factor out a GCF from the first 2 and factor out a GCF from the 3rd and the 4th. So far, so good. Now here's where the magic happens. This is still addition. Still addition. Okay? If the groups match, 2s plus 5 and the 2s plus 5, are these 2 groups the same? If they are the same, you can factor that group out as a GCF. Meaning, since this is multiplying a 2s plus 5 and this is multiplying a 2s plus 5, you can pull out a 2s plus 5 from both of these 2 terms. Think of it like me taking this thing that's in parentheses and this thing that's in parentheses out. And what you're left with are the 2 GCFs by themselves. Those things would be here, and the 2s plus 5 goes there. There's only one group that when you pull out that GCF, that's what's in front because it multiplies both of those things. We do not write it twice. We do not write it twice, and that's something that is a common mistake. So if you understand that, then that is why this thing works. Let's check it by foiling. This times this is 10s to the 3rd. That's your first term. This times that is your second term. This times that is your third term. This times that is your fourth term. I'm hoping you see how it works. The key to it, GCF once, GCF again, do the two groups match? If they do, factor out that's one parentheses, and these GCFs go in the other parentheses every single time. I don't know if that made sense to you or not, but I'm going to find out right now. Here we go. Let's do number 3 together. The first thing that we do, is there a GCF of all 4 terms? No. There are 4 terms. So with these 4 terms, I am going to think factor by grouping, and I'm going to treat these first 2 as a group. And I'm going to look for a GCF of that group. If you know what the GCF is of those first 2 terms, please say it out loud. I heard a lot of people say 3x squared. Parenthesis. I'm going to put up parenthesis for this red group. If you know what goes inside the parentheses, tell me the first thing that goes in the parentheses. 2x, I believe. If you know the second thing that goes in the parentheses, tell me, say it out loud. I agree with you who said plus 3. That is our red group, terms 1 and 2. What we're going to do now is we're going to switch over to blue, and we're adding stuff to it. It's still addition. Now, when you look at 2x plus 3, is there a GCF of it? Kinda. You cannot pull a 3 out of the 2x. It doesn't work. What I'm going to recommend that you pull out of this thing, there's really not much you can do other than this. Let's pull out an invisible 1. Because 1 times 2x is 2x, and 1 times 3 is 3. Now, if I do that, do the 2 groups match? That is a reason why I had you write down, sometimes you will use an invisible 1. That invisible 1 will make 2 groups match sometimes. Sometimes you need to do that. Because we want the first group to multiply, and I want the second group to multiply. It wasn't multiplying, and I'm still adding the blue group to the red group. So the next step, because this is still addition, is I'm going to have a parenthesis here. What can I factor out of both of these 2 things? What's in my first parenthesis?
2x plus 3.
If you said 2x plus 3, you are right. The second parenthesis is where I'm going to check for understanding. I hope you know what goes in there. What do you think it is? Say it out loud.
X squared plus 1.
Well done. You guys understand. Few other things that I need to mention, because remember, they're trying to trick us, and they're going to elevate your game, meaning they're going to make this stuff and make you smarter. Is there a GCF inside here? Is there a GCF inside there? No. You should always double check. Does it factor further? Is there a difference of squares? Is there a trinomial factoring? If so, you're going to do that. Otherwise, you can check by foiling. Yes. Yes. The O and I sometimes come out in different orders depending on what you multiply. And if you foil out, you'll see that it comes out to be that thing. Okay? Now, how are they going to make this harder and try to trick you? Sometimes they're going to have a GCF of the entire thing, like number 7. Is there a GCF of all 4 terms?
Yes.
What goes into all 4 terms?
4.
I'm going to use a bracket just because this thing is a big thing, and I'll get rid of the bracket in a second. But if I were to pull out a 4 from all 4 terms, what goes inside the bracket? 8 x cubed. Plus or minus? plus what? I'm sorry, what's the second term?
4x.
What's the third term? And the last term.
No, it's 12x.
Thank you. Thank you. Let me erase. Let me find my eraser. And the last term?
3.
Do we agree? Okay, so now what they're doing is they're putting in GCF factoring inside a problem that has 4 terms. And if there's 4 terms, we should see, can we factor it further? The way we're going to do that is we are going to look for factoring by grouping. We look at our first 2 terms. These are our first 2 terms. Is there a GCF of that? What is it?
2.
So now I'm going to have my bracket and I'm going to put just a 2. 2x squared. That's your red group. Make this a little bigger. What goes inside the parentheses? What else? Okay. I'm going to switch colors. Terms 3 and 4 are being added to this thing. Is there a GCF of terms 3 and 4?
Yes.
What is it? This 3 is being added. This blue group is being added to that stuff. So don't think it's multiplication yet. It's still an addition problem. There's parentheses, and then there's a bracket. What goes inside the parentheses?
4x
Plus what? Do the 2 groups of parentheses match?
Yes.
By the way, that is a good checkpoint for you. If they don't match, you're doing something wrong. If it doesn't match, you've either not pulled out the right GCF, you've made a simple algebraic mistake, like maybe you thought 3 times 3 was 6. That happens a lot. I see that often, okay? And now it's not factored completely because it's still an addition part right here that we can go another step. So switch colors again, back to red, 4. And my first parenthesis would be what?
4x plus 1.
I agree. We don't need brackets anymore. My next parenthesis would be 2x squared plus 3. I agree with. You pull out the GCFs. That goes here. Those other 2 go in the other group because this is multiplying the first one and this is multiplying the second one, which would be the same thing. If you want, you can double check it, but because it's all multiplication now, it is factored. Promo. What's up? Awesome. That's good news. Uh-huh. Oh, well, that's good. That works for me too. That's awesome. I love it. That's good news. Thank you. Goodbye. Hate it. Yes, it's good news, but it interrupted my recording, and so I'm going to have to record another lesson. But at least it's only this second lesson. Moving on. Number 8. See, lost track. Couple things that I should remind you of. Difference of squares. Can it factor further?
Yes.
No.
No.
Difference of squares. Can it factor further? Those are things you want to double check. Always look to see, can it factor further? Scooting on for number 8. Completely factor your final answers. Why does it say completely factor your final answers? Because sometimes they're going to try to trick you by giving you a more complicated answer, and you may only stop. Completely factor usually means more than once. So let's do, there is no GCF of all 4 terms, so we're going to go into factor by grouping. What's our GCF of terms 1 and 2? I like it. I think it would be 2x plus 5. Do you agree with me? What's our wait, before I go into the GCF of terms 3 and 4, this is being subtracted. And I want a 2x plus 5 remaining. I might want to factor out a negative from this GCF. That might help me as I go into it, because I want this to end up being a 2x plus 5. Is there a GCF that would multiply against that 2x plus 5? What's the GCF? And it's subtracting from that group. That makes a negative 8x. That makes a negative 20. It's not all multiplication yet. And then I bet you know what's now going to go into the first parenthesis and the second parenthesis. In the first parenthesis, you would have?
X plus 5.
Perfect. The next parenthesis?
X squared.
Yay! Are we done? No. Because they're trying to trick us. They said completely factor completely. Factor more than once. We're looking for things that still need a factor. Do you see something else that factors using a previous technique? Don't forget the -1 pointers. Remember, -1 point on a test means you forgot something simple. The -1 pointers, don't forget there's a 2x plus 5 in front of this thing as you keep going. When you factor other things, don't forget anything else that's still in front. The x squared minus 4 factors to? One group of addition, one group of subtraction. X plus 2, x minus 2. Perfect. It's like a length, a width, and a height. Perfect. Last example. Number 11. 3x to the 6th plus 5x to the 4th minus 3x squared minus 5. Is there a GCF of all of those? Okay, so we're going to go right into GCF for terms. I'm thinking factor by grouping. Let's pull out a GCF of terms 1 and 2. X to the what? 4. If you pull out an x to the 4th, what would be left is 3x squared plus 5. Let me switch colors. Now I see a 3x squared minus 5, or negative 3x squared minus 5. Do you know what you can factor out of terms 3 and 4? And you want it to match, you want it to be 3x squared plus 5. Do you know what you're going to put in front? -1. I like it. It's still subtraction though, it's not all multiplication. So now what we're going to do is we're going to have our two parentheses. What goes in the first parentheses?
3x squared plus 5.
What goes in the second parentheses?
X
Yay! Are we done? How come? Does this factor further? Okay. We're not going to forget about this 3x squared plus 5 because some people will. What does x to the 4th minus 1 factor to? Is that a difference of squares? Okay. What times what is x to the 4th? I think that's x squared plus 1 and x squared minus 1. Yay! Are we done?
No.
No.
Can it factor further?
Yes. X squared
Both of these factor further or just one of them?
Just the name.
So we're not going to forget about these other ones. We're going to leave the positive ones alone. X squared minus 1 factors further to what?
X.
That's a nice long answer. I love it. I love it. Great answer. We're going to stop your notes right there.